Troubleshooting and repairing forklift electrical systems. Hello students, it is my pleasure to welcome you all to this lecture on troubleshooting and repairing forklift electrical system. Please relax and take your notepad and electronic pad to jot down information regarding your professional skill. Introduction to forklift electrical systems. Understanding the electrical systems of forklifts is crucial for ensuring their efficient operation and maintaining safety. This lesson will guide you through troubleshooting and repairing these systems with a methodical approach. Understanding forklift electrical systems. Forklift electrical systems are composed of several key components including the battery, ignition switch, starter motor, alternator, and various wiring harnesses. Each part plays a vital role in the overall functionality of the forklift. Batteries. Forklift batteries provide the necessary power to start the engine and operate electric components. They require regular maintenance to ensure longevity and performance. Ignition system. The ignition system ignites the fuel-air mixture within the engine's cylinders to start the forklift. It includes the ignition switch, coil, and distributor. Starter motor. The starter motor uses electrical energy from the battery to start the internal combustion process by turning over the engine. Alternator. The alternator recharges the battery and powers electrical systems while the engine is running. It converts mechanical energy to electrical energy. Troubleshooting electrical system issues. Troubleshooting electrical system issues. Troubleshooting is vital when the forklift is experiencing electrical issues. A systematic approach can help identify and resolve problems efficiently. Common electrical issues. Dead or weak battery, poor electrical connections, or corroded terminals. Faulty alternator, malfunctioning starter motor. Diagnostic steps. Start by visually inspecting the battery for leaks or damage. Check terminal connections for corrosion. Use a multimeter to measure battery voltage. A fully charged battery should typically read around 12.6 volts. Testing the starter motor. If the engine does not turn over, test the starter motor. Locate the starter relay and listen for a clicking sound when attempting to start. If silent, the starter may be faulty. Inspecting wiring and connections. Check all wiring harnesses and connectors for signs of wear, damage, or disconnection. Properly insulated and connected wires ensure effective electrical flow. Repairing and replacing electrical components. Repairing and replacing electrical components. Once a problem has been identified, the next step is to repair or replace the faulty component. This section provides guidance for common repairs. Battery maintenance and replacement. Regularly inspect and clean battery terminals. Ensure they are tight and free of corrosion. If the battery fails to hold a charge, replace it following manufacturer guidelines. Ignition system repairs. Replace worn-out spark plugs and check the ignition coil for proper functionality. Ensure the ignition switch operates smoothly without loose connections. Alternator repair and replacement. Test the alternator output using a multimeter. Readings should align with manufacturer specifications. Replace it if it fails to charge the battery adequately. Starter motor repair. If the starter motor is faulty, inspect it for wear and tear. It might require replacement if it doesn't engage properly. Understanding forklift electrical system safety procedures. Working with electrical systems poses certain risks. Following proper safety procedures is essential to protect yourself and others. Personal protective equipment (PPE). Always wear appropriate PPE such as gloves and eye protection when working with forklift electrical systems to prevent injuries. De-energizing the system. Before performing repairs, disconnect the battery to de-energize the system and prevent accidental electric shock. Safe lifting practices. When handling heavy components like batteries, use appropriate lifting techniques or equipment to avoid injury. Fire safety. Due to the risk of sparks, keep a fire extinguisher nearby and ensure no flammable materials are present during repairs.
In conclusion, by understanding and effectively troubleshooting forklift electrical systems, you can maintain operational efficiency and enhance safety standards. Always adhere to safety procedures and consult professional technicians for complex issues. Troubleshooting and repairing forklift electrical systems can be complex, but understanding the key components and steps involved can help simplify the process. Here's a detailed overview and takeaway from today's lesson. Key components of forklift electrical systems. 1. Battery, the power source for electric forklifts, needs to be checked for charge and corrosion. 2. Wiring. Connects various electrical components. Look for frayed wires or loose connections. 3. Fuses and relays protect the electrical system from overload. Blown fuses need replacement. 4. Controllers regulate power to the motor. Issues may require recalibration or replacement. 5. Motor drives the forklift. May need inspection for wear or electrical faults. Troubleshooting steps. 1. Visual inspection. Start with a thorough visual check of the battery, wiring, and connections for any obvious damage or disconnections. 2. Check battery voltage. Use a multimeter to measure the battery voltage. If it's low, charge or replace the battery. 3. Inspect fuses and relays. Check for blown fuses and test relays to ensure they are functioning. Replace as necessary. 4. Test wiring. Look for any signs of damage or wear in the wiring. Use a multimeter to check for continuity and resistance. 5. Examine the controller. If the forklift isn't responding, the controller may be faulty. Check for error codes and consult the manufacturer's manual for troubleshooting steps. 6. Motor testing. If all else seems fine, test the motor for functionality, ensuring it receives power and operates correctly. Repairing. Replace damaged components. Any worn or damaged parts should be replaced with OEM original equipment manufacturer parts. Rewire if necessary. If wiring is damaged, rewire the affected areas to restore functionality. Calibration. After repairs, ensure that all components, especially controllers, are properly calibrated according to manufacturer specifications. Executive summary. Troubleshooting and repairing forklift electrical systems requires a systematic approach, starting with visual inspections and moving through to testing and replacing components as needed. Regular maintenance and prompt attention to electrical issues can help prevent more significant problems and ensure the safe operation of the forklift. Thank you for staying up until to the end of this lecture. See you again in the next lecture. Happy learning, folks. Remember, safety is a priority in every operation.